Hey guys, it's Mr. Krieger. We're going to do a review. So this is lesson 6 in Unit 9, Trigonometry review. We're going to be having a Castle Learning quiz next week. So hopefully this will help prepare you for that. All right, so make sure you print up the lesson and have this available. This time I'm actually going to have everything already prepared because it's only review. And you can take an opportunity to try the problems yourself before you look at the answer key or watch this to see how you do. All right, so let's take a look here. Here we're given a diagram. The diagram shows the path of birds, the path that a bird flies from the top of a 9.5 foot tall sunflower to a point on the ground 5 feet away from the base of the sunflower. So they're showing this is 5 and that this is 9.5. It says to the nearest tenth of a degree, what's the angle measure x? So this is going to be our reference angle. From this reference angle, we want to label the sides we know. That's opposite from x, and this is adjacent. That's the hypotenuse. We don't have that. So opposite and adjacent, that's going to be a tan function. So you would do tan of x, and it's opposite 5 over adjacent 9.5 like this. And because we're looking for an angle, that's when you're going to use the inverse tan function, tan -1. So you literally type in that function on the calculator, refresh your memory how to get it here. It would be second tan, and now you type in the ratio 5 divided by 9.5, and you'll get 27.75 ... And if you're rounding to the nearest tenth, this rounds to 0.8, so 27.8, okay? Okay, here we have a diagram. Here it says, an 8-foot rope is tied from the top of a pole to a stake in the ground. If the rope forms a 57-degree angle with the ground, what is the height of the pole to the nearest tenth of a foot? So here we know that the rope is 8 feet. The angle that the rope makes with the ground is 57, and we want to put an x over here. So what we're going to do is from this angle here, this side is the opposite, and this side is the hypotenuse. Let me make sure it's not bleeding through. Not really. Okay, opposite and hypotenuse, that's going to be a sine. So you would do sine of the angle. Remember, if you're using sine, not inverse sine, you put the angle there, equals opposite, which is x, over hypotenuse, which is 8. Cross multiply, so you get x times 1 is x. It's 8 sine 57. Okay, don't lose that sine. You're literally going to be typing in 8 times sine, parentheses, 57. Especially if you're using the GeoGebra calculator, make sure you include those parentheses. You get 6.7, which is to the nearest tenth, okay? Okay, in the right triangle JKL in the diagram below, KL is 7, JK is 24, JL is 25, and here's your right angle. Which statement is not true? Okay, so we'll go through each of these and see if they make sense. Tan of L, so our reference angle is L, is 24 over 7. That's opposite over adjacent. Opposite over adjacent, yes, 24 over 7 makes sense. Let's take a look at number 2, which is clearly wrong, but let's see why. Cosine of L is supposed to be adjacent over hypotenuse. So it should be 7 over 25. But they're putting 24 over 25. That would be opposite over hypotenuse. That would be sine, not cosine. So this is clearly the incorrect choice, okay? Okay, so here's a problem where we do not have a diagram. So you have to know how to draw the diagram. Let's take a look at how to do that. A right triangle contains a 38-degree angle whose adjacent side measures 10 centimeters. What is the length of the hypotenuse to the nearest hundredth of a centimeter? So we know we're dealing with a right triangle, so you want to draw yourself a right triangle, right? And the right triangle contains a 38-degree angle. Now you could have put that here or here, as long as the adjacent side to the 38-degree angle is 10. So you're going to put the 10 here on the adjacent side. And it wants to know the hypotenuse, so you're going to put an x across from the right angle. Draw yourself a right triangle. You know, this is a right triangle. You could do it this way, you could do it this way. It doesn't matter. Put the right angle in there. And then you could put the 38 here or here. The key is if you put the 38 here, this is the adjacent side, so this is going to be the 10. All right, so what are we going to do now? So we have our reference angle here. This is the adjacent, that's hypotenuse. We're going to be using cosine. Cosine of the angle, 38, equals adjacent 10 over hypotenuse x. Now, here's where you have to be real careful, because I noticed on homework people make mistakes here. You set it up, cosine of 38 equals 10 over x. Now, when you cross multiply, it becomes x cosine 38 equals 10. And since we want to get x by itself, we have to divide by cosine 38. Literally, you're going to be doing 10 on your calculator divided by cosine parentheses 38. That's what you need to put in, and you get 12.69. Okay, and to the nearest hundredth is 12.69. That's your answer, okay? Okay, next problem. Again, we have a situation, there's no diagram drawn. Since we're doing trigonometry, you know we're going to be having a right triangle like this. It says a 28-foot ladder is leaning against a house. Now, a ladder is the slanted side, because, you know, when you lean a ladder against something, it's on a slant. So that's your ladder. It's 28 feet. The bottom of the ladder is 6 feet from the base of the house. So the bottom of the ladder is 6 feet away from the bottom of the house. So the 6 is on this side. And it wants you to find the angle formed by the ladder and the ground. That's the angle by the ladder and the ground. Now, you might say, what about this angle? That's the right angle. We already know that's 90, so the angle is going to be at the bottom over here. So from here, this is adjacent and hypotenuse. So adjacent and hypotenuse, that's going to be cosine. Okay, cosine of the angle equals 6 over 28, adjacent over hypotenuse. This is where you're going to use that second cosine button on your calculator. Okay, and you type in the ratio, and you get 77.62, and it rounds to 78 if you're looking to bring it to the nearest degree. Okay, let's take a look. Here's a two-part question. It says, as shown in the diagram below, a 12-foot ladder leans against a wall and makes an angle of 72 degrees with the ground. So the ladder makes a 72-degree angle. Down here by the wall, there's a right angle. We know this is 72, and it says find to the nearest tenth of a foot the distance from the wall here to the bottom or base of the ladder. This distance, x. So from this angle, the reference angle, this is adjacent, and that's hypotenuse. So that's going to be cosine. Cosine of 72 equals adjacent x over hypotenuse 12. Cross multiply this. X equals 12 cos 72. And type that right into your calculator, you get 3.708. To the nearest tenth, it's 3.7. Now, explain how this question can be solved using a different trig ratio. Now, what you could have done, because we know the measures of two of these angles, we could find that missing angle there, that 18-degree angle right over here. So instead of using the 72-degree angle, we could use the 18-degree angle right here. In this particular case, sine of 18 is opposite over hypotenuse. We could use sine. Sine of 18 is equal to x over 12. And notice you get the same exact answer either way that you do it, whether you use the 72-degree angle down here or the 18-degree angle over there. Okay, last page. This is also a two-part problem. Okay, in right triangle ABC, AC is 29, AB is 17, and this is your 90-degree angle. Find the number of degrees in the measure of angle BAC, this angle right here. So again, this is another case where we're going to be using the inverse function, the second function, because we're looking for an angle. We know this is going to be cosine again, adjacent over hypotenuse. So cosine of x, the angle, is equal to 17 over 29. Second cos, which is the inverse, you put 17 over 29, it rounds to 54 degrees. And it says find the length of BC to the nearest inch. Now, you could use trigonometry to do this problem, or you could say, you know something? I know from even earlier in the course that if I have a right triangle with two sides that are given, I could use the Pythagorean Theorem. A squared plus b squared equals c squared. These would be like a and b. The legs have to be the a and b, but this has to be the c. This has to be by itself. So 17 squared plus y squared. By the way, you might ask, why are we using y here instead of x? It's one single problem, and we used x already. So if you're going to be if you're looking for a different thing, a different missing value in a problem, use a different variable. So we'll use y. So 17 squared plus y squared equals 29 squared. This I think you're good with. You know how to do the Pythagorean theorem. The thing is, just to keep in mind, you don't always have to resort to trigonometry. Given two sides of a right triangle, you could find the third side using this technique. But you could have just as well used the trigonometry, you would get the same answer. Okay?